A geometric series is the sum of all the terms in a geometric sequence. So it's a geometric sequence with all the terms added together. Prove that the sum of the first n terms in a geometric series is a times r to the power of n minus 1 all over r minus 1. So the sum of n terms is the first term, which is a, and then the second term, a times r squared, and so on, all the way up to ar n minus 3, ar to the power of n minus 2, and then the final one, ar to the power of n minus 1. So that's the sum of all the terms. If we multiply that through by r times the sum is ar plus ar squared plus ar cubed, all the way up to ar n minus 2, ar n minus 1, and then ar n. So if we multiply each one by r, the power goes up by 1 each time. Then, if we take away, we can see that all these are going to cancel. So ar is in both, ar squared is in both, ar cubed will be in both, and so on. All these will be in both. So if we do the bottom one, take away the top one, we'll say r times Sn minus Sn. And then the only thing that will be left is arn minus a. So all the other ones are going to cancel out, and we're just left with this part. Then we can factorize out Sn on the left, factorize out a on the right. So Sn times r minus 1 equals a times r to the power of n minus 1. And then to get the sum by itself, divide both sides by r minus 1. So a times r to the power of n minus 1 all over r minus 1. A geometric series has first term 10, common ratio 2. So a is 10, r is 2. Find the value of S10, so the sum of the first 10 terms. So we're looking for the sum of the first 10 terms of the series. So Sn, our formula, Sn is a times, we had Rn. We can do it either way around. So Rn minus 1 over r minus 1. And I'll just make a quick note for you. It also works as a times 1 minus Rn over 1 minus r. So they're equivalent. They're just timesing top and bottom by -1. So either of these formulas, either one works. So we're just substituting in. R is 2, A is 10, and N is 10 as well. So it's using the top formula, 10 times 2, and N is 10, so 2 to the power of 10, take away 1, over R, which is 2, take away 1. The sum of the first 10 terms is this, and we can just type it into the calculator. So 10 times 2 to the power of 10 minus 1 over 2 minus 1, and we get 10,230. Okay, one for you to try. Give it a go. So this time we have A as 4, R as 3, and N is 10 again. So the sum of the first 10 terms is A, which is 4, times R to the power of N, 3 to the power of 10, take away 1, over R minus 1, 3 minus 1. And again, we can just type that into the calculator. So 4 times 3 to the power of 10, take away 1, over 3 take away 1. And we get 118,096. A geometric series has first term 12. A is 12. Common ratio, 2/3. Given the sum of the first k terms is more than 34, find the smallest possible value of k. So we're using our sum formula. So the sum of n terms is a times 1 minus r to the power of n over 1 minus r. I've used this version, which tends to be better when r is less than 1. So the denominator is going to be positive. And I'm just going to substitute in and find out what n has to be to get an answer of 34, for the sum to be 34. So what does it have to be? So a is 12 times 1 minus 2/3 to the power of n over 1 minus 2/3. So times both sides by 1/3 and then divide by 12. So 34 times 1 minus 2/3, which is 1/3, then divided by 12 is 17/18. So 17/18 is 1 minus 2/3 to the power of n. Let's take away 1 from both sides, or bring the 2/3 n over. So 2/3 n, 2/3 to the power of n is 1/18. 1 take away 17/18 is 1/18. And then we will log both sides. So log 1/18 equals log 2/3 to the power of n, and the n jumps to the front. So n times log 2/3. Then to get n by itself, we're going to do log 1/18 divided by log 2/3. And we'll just type that into the calculator. Log 1/18 over log 2/3, 7.1. We've got 7.1. So we can't have the 7.1 term. So at 7.1 terms, it's equal to 34. So the smallest thing it can be is 8. The 8th term will be over 34. So it's the 8th term. Okay, one for you to try. Give it a go. So again, using the sum formula. It doesn't matter which way round, so you could do a times rn minus 1 over r minus 1, or this way round. It's the same formula. So the sum is equal to 30, and that's a, which is 20, times 1 minus 2/5 to the power of k over 1 minus 2/5. So 1 minus 2/5 is 3/5. 3/5, I use the calculator. So 3/5 of 30 is 18, and then divided by 20 is 9/10. So 9/10 is 1 minus 2/5 to the power of k. So 2/5 to the power of k is 1 minus 9 tenths. Log both sides. So k log 2 fifths equals log 1 tenth. So k is log 1 tenth divided by log 2 fifths. And we get 2.5. So at 2.5 terms, it's equal to 30. So the smallest thing k can be is 3. And we can check our answer. So we can say 20 times 1 minus 2 fifths to the power of 3 over 1 minus 2 fifths. We can see that is 31. If we change the 3 to the 2, we can see it's lower than 30, it's 28. So k is 3.